Planet Earth, the blue planet, is dominated by water. Oceans cover over 70% of the Earth's surface, yet we know more about the surface of the Moon than we do about the depths of our own oceans. The ocean's depths are home to unique ecosystems, strange creatures and resources that could hold the key to our future. The ocean's depths are a realm of crushing pressure, frigid temperatures and perpetual darkness. Our journey into the ocean's mysteries begins with understanding its depth. The ocean floor is not a uniform surface, but a dynamic landscape of towering mountains, vast plains and trenches that plunge miles below sea level. As we continue to explore this final frontier, we must do so responsibly, with an eye towards conservation and sustainable use. For the ocean's depths hold not just mysteries, but also the potential for our future. Measuring the ocean's depth is no easy feat. The advent of sonar technology in the 20th century revolutionized our ability to map the ocean floor. Sonar, which stands for sound navigation and ranging, uses sound waves to detect objects and measure distances. By emitting sound pulses and measuring the time it takes for them to bounce back from the seabed, scientists can create detailed maps of the ocean floor. Modern sonar systems, such as multi-beam sonar, can map vast swathes of the ocean floor in high resolution, revealing the intricate details of underwater mountains, canyons and trenches. Despite these technological advancements, vast areas of the ocean floor remain unmapped. Autonomous underwater vehicles, AUVs, and remotely operated vehicles, ROVs, are increasingly being deployed to explore these remote regions. Each new discovery brings us closer to unraveling the mysteries of this vast underwater realm and highlights the importance of continued exploration and research. As we descend from the sunlit surface waters, we enter a realm of diminishing light known as the Twilight Zone, also called the Mesopelagic Zone. This zone extends from 660 feet to 3,300 feet below the surface, a region where sunlight dwindles to darkness. Many animals in the Twilight Zone have evolved large, sensitive eyes to capture any available light, while others have developed bioluminescence, the ability to produce their own light. One of the most fascinating phenomena in the Twilight Zone is the daily vertical migration, where trillions of creatures migrate hundreds of feet towards the surface at dusk to feed, returning to the depths before dawn. Studying the Twilight Zone and its inhabitants is crucial for understanding the ocean's overall health and the impact of climate change on marine ecosystems. Venturing deeper into the ocean's abyss, we reach the Midnight Zone, also known as the Bathypelagic Zone, a realm of perpetual darkness where sunlight never penetrates. Despite these extreme conditions, life persists, showcasing remarkable adaptations to thrive in this unforgiving environment. Many are bioluminescent, using light-producing organs to attract mates, lure prey, or deter predators in the pitch-black depths. One of the most intriguing aspects of the Midnight Zone is the presence of hydrothermal vents, fissures in the ocean floor that spew superheated water rich in dissolved minerals. These vents create oases of life in the otherwise barren depths, supporting unique ecosystems that rely on chemosynthesis rather than photosynthesis. The study of this zone is crucial for understanding the limits of life on Earth and the potential for life in other extreme environments, both on our planet and beyond. Beneath the depths of the Midnight Zone lies the abyssal plain, a vast flat expanse that constitutes the deepest part of the ocean floor. This region, extending from 13,000 feet to 20,000 feet below the surface, covers a significant portion of the Earth's surface, yet it remains one of the least explored environments on our planet. The abyssal plain is characterized by its uniform flatness, the result of millions of years of sediment accumulation from the surface waters above. Despite the extreme conditions of crushing pressure, frigid temperatures and perpetual darkness, life finds a way to thrive even here. Many of these organisms are small and unassuming, dwelling within the sediment, feeding on the organic matter that drifts down from the surface. The abyssal plain, despite its apparent desolation, plays a crucial role in the ocean's ecosystem. It serves as a massive carbon sink, burying organic matter that drifts down from the surface, thereby regulating Earth's climate. As we continue to explore this vast and mysterious realm, we can expect to uncover even more secrets about the resilience of life and the interconnectedness of Earth's ecosystems. Venturing deeper still, we enter the hadal zone, named after Hades, the Greek god of the underworld. This zone encompasses the deepest trenches and depressions on Earth, plunging to depths greater than 20,000 feet. The hadal zone is a realm of extremes, home to creatures that have pushed the boundaries of adaptation. One of the most iconic inhabitants of this zone is the deep-sea anglerfish, a creature with a bioluminescent lure dangling from its head, attracting prey in the pitch-black depths. Other denizens of the hadal zone include giant amphipods, crustaceans that resemble oversized pillbugs, and xenophyophores, single-celled organisms that are among the largest known. The hadal zone is also home to hydrothermal vents, which provide heat and nutrients that support unique ecosystems. Exploring the hadal zone is a formidable challenge, requiring specialized equipment and technology. The scientific rewards of studying this extreme environment are significant, offering insights into the limits of life on Earth and the potential for life in other extreme environments. The deep ocean is a pressure cooker, literally. As we descend into the ocean's depths, the weight of the water above exerts immense pressure, increasing by 1 atmosphere for every 33 feet of depth. Yet, despite this crushing pressure, life thrives in the deep, a testament to the incredible adaptability of organisms. Deep-sea creatures have evolved a variety of physiological adaptations to cope with this extreme environment. One key adaptation is the lack of air spaces within their bodies, which would collapse under the immense pressure of the deep sea. These adaptations not only allow creatures to survive in the deep, but they also offer insights into the potential for life in other extreme environments, both on Earth and beyond. The ocean's depths, long considered a hidden and inaccessible realm, are increasingly recognized as a potential treasure trove of resources. As terrestrial resources become depleted and the global population continues to grow, the ocean's depths are attracting attention as a potential source of food, energy, and minerals. From vast schools of fish to untapped oil and gas reserves, the deep ocean holds promise for meeting the needs of a growing planet. Sustainable fishing practices and careful management are crucial to ensure that these resources are not overexploited. The deep ocean is also believed to hold vast reserves of oil and natural gas, though the environmental risks associated with deep-sea drilling are significant. In addition to food and energy, the deep ocean is also a potential source of valuable minerals such as polymetallic nodules rich in manganese, nickel, copper, and cobalt. The ocean's depths, far from being a remote and irrelevant realm, play a crucial role in regulating Earth's climate and supporting life as we know it. The deep ocean acts as a massive carbon sink, absorbing vast amounts of carbon dioxide from the atmosphere and locking it away in the depths for centuries. This process helps regulate Earth's temperature, mitigating the effects of climate change. The deep ocean also plays a vital role in the global ocean circulation system, which transports heat around the planet. Cold, dense water from the poles sinks to the ocean floor and flows towards the equator, while warmer surface waters flow towards the poles, creating a continuous loop that helps distribute heat and regulate Earth's climate. Despite its importance, the deep ocean is facing increasing threats from human activities, including climate change and pollution. The deep ocean, the largest and least explored habitat on Earth, holds immense potential for scientific discovery and technological innovation. As we continue to develop new tools and technologies, we are poised to unlock the secrets of this vast and mysterious realm, gaining a deeper understanding of our planet and the life it harbors. One of the most exciting frontiers in deep-sea research is the development of autonomous underwater vehicles AUVs. These robotic explorers can operate independently of humans, diving deeper and staying submerged for longer periods than ever before. Equipped with advanced sensors, cameras and sampling devices, AUVs are providing unprecedented access to the deep sea, allowing scientists to map the seafloor, study marine life, and collect data on oceanographic conditions. The development of new materials and technologies is also essential for advancing deep-sea research. In conclusion, the ocean's depths, a realm of mystery and wonder, are integral to the health of our planet and the future of humanity. From regulating Earth's climate to providing valuable resources, the deep ocean plays a vital role in sustaining life as we know it. Yet this vast and largely unexplored realm is facing increasing threats from human activities, from climate change and pollution to overfishing and deep-sea mining. As we continue to explore and learn more about the ocean's depths, we must also recognize our responsibility to protect this vital ecosystem. Sustainable management practices based on sound science and a deep respect for the interconnectedness of all life are essential for ensuring the health of the ocean for generations to come. The future of our planet depends on it.